Hi friends, today we are going to saw about NCERT Syllabus Mathematics Chapter 1 Exercise 1.1. First question. Use Euclid's division algorithm to find the HCF of 135 and 225. We need to use division algorithm. That is this one. That is which one is we need to find the greatest one and the smallest one. Here, the greatest one is 225 and the smallest one is 135. In this, we need to apply the division algorithm. That is, the division algorithm formula is A is equal to BQ plus R. So, here, A is equal to 225 and B is 135. So, I wrote in the place of A, that is 225 and 135 in the place of B. We don't know quotient and remainder. So let's start dividing. See here, I'm dividing 225 with 135. 1 into 135 gives 135. Balance is 90. So here quotient is 1 and remainder is 90. So I written here. After that, we no need left hand side. We need only right hand side because see here we no need take in that which one is the greatest one, that one is A and smallest one is a B. So I kept here this one as a A and this one as a B. Why I am applying again means because here we read that if R is 0, the D is the HCF of C and D. If R is not equal to 0, we need to again apply Euclid's lemma. So that only I applied again. See here, now we don't know the Q and R. So I'm going to divide now. See here, 135, 190 is 90, 2 will come, balance is 45, 290 will not come. So quotient is 1 and remainder is 45. Here also the remainder didn't came as 0, so we need to apply again. In this, biggest one is 90 and smallest one is 45, so A is 90 and B is 45. See here, 145 is 45, 245 is 90. So, quotient is 2 and remainder is 0. Now, we need to stop the Euclid's division algorithm. Here, B is the HCF of A, B. This is A and this is B. Here, what is HCF B? Last step, what is B? Here, this is B. So, B is the HCF of A, B. See here, B is the HCF of A, B. You have read this in Euclid's division algorithm. Next question, to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. We need to apply the formula A is equal to BQ plus R. For this lesson, we have read only this formula alone. Here what they said, up to 6q plus 5. So we need to write up to that. Number is what? 6q plus 0, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. So see here, I'm dividing this 6 into 2 3s are 6 and q plus 0 first number, because first number is 6q plus 0, so 6q plus 0. This is instead of 6 I'm dividing like this. If you this is 2 3s are 6. Okay, see, q is some integer. While you are multiplying, you can get a odd number or even number. If you multiply it with 2, whether it is odd number or even number, whenever you are multiplying with 2, you will get the whole term as even number. For example, this number is known as 5. So 3 5s are 15. 15 into 2 we get 30. So if it is a 30 means 30 plus even number, we will always get even number. Next, you see here, I'm dividing this. If it is this is even number, the even plus on odd number will give odd number. Next one, 6q plus 2, that is, this is a even number, even plus even gives even. Next, even plus odd gives odd. 6q plus 4, which is Even plus even gives always be the even. Next, 6 cube plus 5. This is even plus add will give add. When n is equal to 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, it is odd because we said that 6 cube plus 5 is odd, 6 cube plus 3 is also odd, and 6 cube plus 1 is also odd. Hence, any positive odd integer is of the form 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5, where q is some integer. This was mentioned in question. Next, third question. 3. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in same number of columns. What is the maximum number of columns in which they can march? This is the question. First of all, we need to write given. What they given? The maximum number of column is HCF of 616, 32. This is the given. We need to use EDI, that is Euclid's division algorithm short form, for finding HCF. See here, which one is greater, 616 or 32? 616 is a greater. So here, 616 is A and 32 is B. So, what is the formula to find HCF? A is equal to BQ plus R. We need to apply. This is A and this is B. I written here, A is equal to 616 and B is equal to 32. And we don't know Q and R. So, let's start dividing. Fourth question. Use EDL, that is Euclid's division lemma, to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. This is the question. The answer is, let x is equal to 3q or 3q plus 1 or 3q plus 2, where x is some integer. When x is equal to 3q, on that time what we have to do means, we need to square on both sides, that is x square and 3q whole square. What is x square is equal to 3 into 3, 9. So 9 q square. So we will take, we will divide the 9 into 3 into 3, that is, we will take the 3 commonly outside. So 3q square, 3 into 3q square. Here 3m, this is this number in the bracket number, this is where m is equal to 3q whole square. This number I'm take it as a m. So I'm keep it as 3m. Okay. We got this. Which one? We find what is 3m. Next we need to find 3m plus 1. See. Where x is equal to 3q plus 1. So we need to square on both sides. X square and 3q plus 1 whole square. How we can take it commonly outside, like that we need to see. But here we will apply the formula, because 3q plus 1 is came. So plus 1 came means a plus b whole square we can use. A plus b whole square. What square? A square plus 2ab plus b square. Here a is known as 3q, that is 3q whole square. See, a square means what? Here a is 3q. Square means you should not write here 2. 3q whole square only you should write. Next what? 2ab. So 2 into a, 3q into b, 1. Next b square what? 1 square. This one. 3 into 3, 9. 9 square plus 2 3s are 6q plus 2 3s are 6q into 1 also same 6q. So plus 1 square. Next 3 into 3q square plus 2q square. See, I'm again dividing it with this. Sorry, I'm taking outside. So what will came? 3 3s are 9q square. 6 means 3 2s are 6q square. So I'm taking common outside. See, 3 2s are. So 2 keeping 3 common outside. 3 3s are 3 taking commonly outside. So 3 into 3 square plus 2 square, close bracket, plus this 1. This bracket I'm keep it as a m. See here m is equal to 3. 3q square plus 2q. So 3 here I'm take this number as m, so plus 1. So see 3m plus 1 also we found. Next we need to find 3q plus 2. Now I'm taking x is equal to 3q plus 2. So okay, we need to squaring on both sides, x square 3q plus 2 whole square, which gives a plus b whole square formula. While pluses came on the time, we need to apply the formula. Here what 3a plus b whole square equal a square plus 2ab plus b square. A square what 3 cube whole square plus 2 into 3q into 2 plus 2 square. Next 9 square plus 12 cube plus 4. 9 square plus 12 cube plus I'm dividing the 4 into 3 plus 1. We can take like this also. Next 3 into 3 q square. I'm taking commonly taking out. I'm commonly taking outside up to the 3. See 3 I'm taking commonly outside. I'm taking commonly outside. This has came here and this number I'm taking as m. Okay, you should write in bracket. Then only I know that. Then only you know that this number as we have taken as m. So what this is a m means 3m plus 1. Whichever we are taking 3q plus 2 or 3q plus 3, we always the number will come as a 3m plus 1. So here square of any positive integer is of the form 3m or 3m plus 1.